Yeah, today we are still running this playlist, and here is the module 3. So we are going to deep into embedding and vector representation. Previous video we are covering, if I just recover you, that's document and processing chunking. So I hope you remember everything. If you're not, you can watch again the video. Okay. Now today we are going to embedding and vector representation. So the mathematical heart of the RAG. Before I explaining, let me ask you first, what do you think is mean embedding? A beginner say it's some kind of number that represent text. That is not totally answer, and it's pretty good, right? But the magic is when those number work the way do what geometrically has a do meaning. Okay, that's is important. Is not only give the number to the text, is about also is give the meaning of that. Okay, let's build this from obviously zero. Uh, we are going to in deeply. So the big picture why embedding exists. The fundamental problem computer understand number language is text. So that's the problem. Language is just only text. So dog and puppy are similar. Dog and airplane are different. Bank, finance and banks, rivers and mean different thing. Okay, answer the converts word into the number back to such a similar meaning, similar number. I hope you understand. This was easy. So how embedding work? That's important. How embedding really work? Okay, let's dive. What is embedding? A simple definition. A embedding is a number as a vector that's repeated the meaning of a piece of text, such as the text with similar meaning have similar vector. Okay, that's perfect. I love my job. Okay. So I adore my puppy. This is the similar and stock market crash is totally different. It's just word. So they have the word is a number and number is the meaning. So and that's it. I hope you understand. This is totally very simple concept, but technically it's so hard. Okay, first principle journey from the word to vector. Okay, how we define the word as vector? The old way, one hot encoding why it fell. Before modern embedding, the simplest approach has one hot encoding. Back to vocabulary cat, dog, puppy, airplane, car. Okay, so car 00000. That's mean this it was the old way, and that's not the meaning in a word. Okay, the problem with this one hot encoding distance the dog and puppy separate so same. Distance the dog and airplane is also the same. That is no meaning find. We just give the text into the number that can read computer, but that's not give any meaning. So this is the problem, and every word is externally the same distance from the every other word. There is a 0 centimeter information one hot variable. The key inside distribution centimeter. You will show word by company keep. Okay. So that's the foundational behind all model embedding. The key inside distributions embedding will show no. Okay, the dog appeared, the near pet, bear, less, bird, and puppy, cat. Okay, puppy, near, pet, dog, and this is like a vocabulary. I hope you know the vocabulary similar sentiment vocabulary. Synonym is kind of like they're similar contact and they will be have the similar vector. Airplane appear the fly, airport and public fine. If you two words appear the similar content, they will like to have similar meaning. This inside literally how neural embedding model are trained. how embedding model are trained. Training process similarity. Billion of text sentence from the internet. Predict the missing word. That's we know. So the marks so model predict dog. Uh, so this is the prediction. Are the two sentences similar? The dog, the puppy. So human level similarity 1, 0, 1. So this is the prediction. There's a geometric meaning, critical map. Think embedding it like a GPS container. So Newark is like a 1471 and 97 lost. It's like a GPS location. So Booster is like that way, and Los Angeles this number. So Newark and Booster are closer, similar to context. So they are closer. That means they are similar to context. And Newark and LS is far different. That's the reason they are number is long. So embedding work are same way, but the instead of the two dimension let learn, and we have a lot of dimension. Okay, sir. 150 1536 dimension. This is a lot of, and there's 3000 dimension have also. So the king and queen analyze meaning. So the king plus king minus man plus woman. So king minus man plus woman is queen. So this is the embedding. Okay, visualization to this simple queen king like a gender distribution. Understanding embedding dimension. What does dimension mean? Vector 1. One number, every little information like a distribution a city with only latency. 2D vector. Two numbers still very limited. 3D vector. 3D number is basic speaking information like there's let, learn, and attribution. And there's a 6 7,168 D vector. The region details and represents each of dimension, encoder some aspect and meaning. Okay, vector even richer representation, and this is the maximum details available OpenAI model. Okay, what does individual dimension represent? The honest answer we don't know exactly. They are learned automatically. But conceptually dimension might be captured. Positive, negative, positive, negative dimension. Okay, for now. No single dimension is fully interprets. The meaning is embedding from all dimensions together. Distance matrix, how we measure the similarity. Okay, that is the question. The core question, how similarity to vector. We have two main method. Let's understand each from the scratch. Okay, right. Matrix one, constant similarity. Constant similarity is a measure the angle between the two vector, distance between their street. Okay, think a vector throws the pointing from the original dot. Small angle is high similarity, large angle low similarity. The formula, that's the code. And break down the every symbol. So it's a mathematical formula. I hope you know that. Okay, that's a simple example 3D vector. So we just create a 3D vector. This is the vector dot. We need to this. We just labeling our own data set. So we have dog and puppy. So then we are using this dot product and then line for normalization using the mathematic numpy, and then return the dot product. This is the mathematical. So we just using the code. So then after that we are very similar, very distant. Dog Then we are put dog versus puppy, dog versus airplane. So we just put um, why consider similarity for the text embedding. Key insight: consider the similarity, ignore the magnitude length of the vector, is only the trace on the graph. This is matter because dog showed the vector only word. I have a dog home might be have longer magnitude, but this would be okay. Equidistance distance. Institution the straight line distance between two points in the face. Okay, this is the distance between the 2 points. The problem is introducing the tag and the normal shortest. I love the dog and he is great. This is between largest difference small. This constitutes similarity is the more syntax calculation. When it is workable, when the vector are already normalized until the vector image is embedding some specific before dot product multiplication dot similarity. Example, okay. So relation between metrics. So there is a mathematical term and using the matrix and the similarity and matrix comparison summary, questions in and best for text, and limitations, flow and compilation. And dot product the normalization vector spreading it. Vector for the text is not equal to with text. So vector that's gonna be work good. Okay, dimension fit. Okay, I need to sum it. Oh, sorry. Dimension trade-off. Dimension. Characterization. Faster search. Says it's short. Good for simple sentiment search. Less means and lower accuracy on complex tasks. Example, all mini LLM L4B is very popular open source. Good balance for separate and quality. Standard for any mini verb-based model. High quality. Okay, was a bit dimension. That's everyone using this one. So the part two, embedding and model overview. I want you to read first some second about that. I'm just reading some some drinking. Sorry, some water I need. Okay, OpenAI embedding model text embedding three small from LangChain, OpenAI. There's OpenAI model running. So embedding. So we are calling text embedding three small and vector embedding. What is the reference policy? Let's make the word into text into the vector. And sorry, embedding. The number is embedding the vector. Yeah, I'm right. So and this is the code. And text embedding three largest higher quality. This is largest model. But most of the people using this small. This is good enough for GitHub. So dimension reduce feature, OpenAI model. There is you can use dimension model feature. That's you can your own use case and make your own way is totally depend on up to you and your company. And you need to research on it. It's not about that. I told you that's good. Okay, find this open source alternative. Why? Why using open source? Cost, zero a cost, interface and run locally, no pair of the token search. And privacy, data never leave for interfaces, that's good be. No internal travel and this is customized fine-tuning and domain adoption, offline work and without interface. Open source embedding model, there is open source embedding model. Mini around 4 is Ulama uh, Gamma. Okay, Gamma is perfect for that. Embedding with Ulama, local open source, so using Ulama. And method embedding Gamma. This Gamma is a powerful model for like a Gemini, so you can use also that. Okay, I'm not going to deep dive the code. So input Ulama and this is the code. I hope you can understand and use by you also. And embedding Gamma with a Lantern. Lantern is going to be more easy for your code base. This is help you. So available Ulama embedding. There's a embedding this Ulama using. So it's open source. So you don't need to API. Choosing the right embedding model. That is one of the important thing. And everyone need to focus on that. The leaderboard, how to choose what is the MTEB. A massive text embedding benchmark is the gold standard for comparison embedding model test model. Find the retrieval requirements query. What to look for the source, the most important rag laboratory was creating better the retrieval. Cost versus quality. This is MTEB, massive tax embedding benchmark, and cost versus quality decision framing. Practical cost and comparison, and there's some question that's going to help you hands-on comparison and digital model, open source and OpenAI. Here the code. Okay, then you can comparison and evaluation by your own self. Luncheon embedding implementation. There is a section. The embedding information plus into automated section embedding classification implementation and the complete LangChain embedding implementation. Here the code. Production reading embedding pipeline. Visualization embedding understanding space. This is code. I'm not gonna be deep dive into everything about the code. Just share this notebook and I want you to try to understand and using ChatGPT or any LLM to understand the code. Fail model and interview preparation. Let's deep dive into the fail model and interview preparation. Embedding model mismatch. Document embedding with model A, require embedding with model B. Complex random variable and different speech always use the same model for both document and queries. So using the same model is gonna be perfect. Context length, chunk with the token and model will get the maximum simplicity so find that way. And that is the perfect. And embedding wrong thing using two documents. out of the domain vocabulary. Model are poor understand of the domain specific term. Okay, semantic mismatch in software. Very short chunk. Create a weak embedding. See the table beyond it. Okay. Uh, bang. Okay, this is the failure, and the interview question is the most important. So now we are focusing on the interview question, and you give me answer by your own self about this reading this module 3 and understand the interview question. Explain the what is embedding and why they are used from the right. This is the important question. Give first your own answer, then I will do this strong answer. Embedding depends on the vector representation of the text that includes sentiment meaning into multiple dimension, number space. The functions provide the text with a similar meaning, have the vector point in the similar direction measured by the cousin similar with this is enabled to semantic answers when user asks how do I get a refund. We can find the document about the return policy even though the word different because they are embedding or close vector space rag embedding or their between the natural language query and they are always okay. That was a strong question. I was description something. Okay, why consider similarity over the equidistant distance embedding? Okay, that is a strong similarity over equidistant distance for embedding. Consider the similar measure the engineer between the two vectors, while addition is measure the distinct one distance between their endpoint. For text embedding, consider similar. And because of the investor in the back dimension and the short query, long distribution can be at the same. Okay, that was the deep dive answer, strong answer. How would you choose between text embedding three small versus large? That's important. How you think about that? After the text embedding small, it for an age cheaper at 0.0 million token versus 0.1 million, and this MTEB score are only marginally lower than third largest most readable task, only upgraded to large when I demonstrate through the evolution that small information, typically high threats dimension like a medical or legal, where every preference point is statistical occurs, or when semantics relation are extra substantial, also consider a new dimension, reduce spacer 3 and the 3 dimensional. Okay, this answer is like a created, yeah, but you gave your own answer, okay, by your own self. Don't be rigged like that, okay, and don't predict like me practice. Okay, fine. What is the difference between embedding query versus embedding document? Okay, that's an important question. They are serve different roles. Retrieval pipeline. Embedding query is the call is query time on the user question, and embedding single text and compromising retrieval interface embedding in document. It's called during the interrogation with a knowledge base based on content. It's possible to build of the document chunk and storage from some of model like E5 and PG5, and those are not installation because of the model different preference during the training. Querying the embedding have the quality was preparation with the phrase embedding have the price. Mixing them would be result queries and document living in significantly different vector space. During routing the retrieval from the screen-embedded model like OpenAI, this function are the question, but the interface will be still maintained for the certain and future processing. Common mistake: higher dimension always better embedding. That is not good. After this, those are more dimension distance return and text embedding small and dimension is not written. Okay. Uh, I can switch embedding model later. Switch embedding model require complex reinforcement for your entire knowledge base back to n dimensions could not be capable to choose the model at the same time. Embedding understand the extreme meaning word. Embedding capable statistical pattern from training data. They can fail only the very dimensionless logic there. More similar embedding score. Dimensional retrieval highs consider similar meaning, not the necessary function. Embedding query and embedding document are the same. For this essential model, free embedding are always worse than paid. This not be like look. It's not be like this, and that's the focus on the engineering mindset. Engineering mindset. What is the real rack embedding? Think about. Look, is the embedding model or they want? Changing latency meaning, embedding everything. Okay, let me think. I'm just 26 minutes talking non-stop. Okay, let's focus engineering mindset. Look at the embedding model and just read you by yourself. And this is engineering mindset. I don't want to read in loud. I just want to read by mindset and try to understand this. Okay, let's focus in exercise. Beginner exercise. Calculate, consider similarity. All the pair necessities, all the pair and thus is the all. And here are the results and the 18-20% rules. Okay, please read someone 18-20% rules. Oh, without me, there is no one. So I need to wait. Sorry, I was trying. Okay, module 3, the summary about 20 or 80 rule, understand. Text, listen numbers and with the meaning, listen numbers and listen. You ready? Okay, we're done. Alright, we're done. Module 3. Wow.